Hello, everyone. Welcome back to the Building Cyber Resilience, a practical guide to cloud security. I'm really excited to dive into today's topics because honestly, this is something that trips up way more people than it should. We are talking about the cloud share responsibility model. You know, figuring out who's actually responsible for securing what in this whole cloud ecosystem. Look, I totally get it. At the first glance, this stuff can seem pretty dry, maybe even a little boring. But there is a thing. Understanding this model isn't just helpful, it is absolutely essential. If you want to keep your digital assets safe, and trust me on this one, I have worked this way too many organizations that had to learn this lesson the hard ways. At the end, nobody wants to be in a situation. So let's start with the basics, but only after the introduction video. Welcome back. Before we get into the nitty gritty of the share responsibility model, let me quickly remind you what we are talking, or actually we are talking about when we say cloud services. Cloud computing basically gives you on-demand access to assure the pool of clouding computing resources. We are talking in networks, storage, applications, software, so on and so forth. Basically, the whole nine yards. Most of the time, you're probably dealing with the public cloud, where some services providers deploys and maintain infrastructure for multiple customers. Well, in this case, you might think you just access it over the internet. Simple as that, right? But then there is the hybrid cloud, which is where things get a bit more interesting. And honestly, a lot of more complicated. This combines your private or the on-premise infrastructure with at least one public cloud service. Think of it as an extending your local data center into the cloud. But here's the kicker. It needs the exact same level of protection as everything else in your environment. Now, the service model, now the service model, those matters. Why? Because way more than you think, it is what set the stage for the most proper security posture. Because they directly affect where you are responsible for securing your environment. So let's break this down. First up, infrastructure as a service or IaaS. This provides the basic building blocks, virtual machines, networks, storage. You're essentially renting the physical server space. But here's what catches people off guard all the time. You still have to manage the operating system and applications. It's like renting an unfurnished apartment. Sure, you get the space and the basic utilities. What about everything else? That's completely on you. Then we've got platform as a service or PaaS, which takes things up a notch. The cloud provider handles the underlying infrastructure and all the platform stuff, operating systems, databases, web servers. You get to focus on your applications and your data. It's more like a furnished apartment where you just bring your personal items and you're good to go. And finally, software as a service, SaaS, which is probably what most people think of when they hear cloud. The provider delivers the entire application over the internet. Gmail, Salesforce, Microsoft 365, you name it. All you really need to worry about is using the application and managing your data within it. Think of it as staying in a hotel. Everything's provided for you. You just need to manage your belongings. Understanding these distinctions becomes absolutely crucial when we talk about responsibility, as you'll see in just a minute. So what exactly is the shared responsibility model? At its core, it's about clarifying those security boundaries between the cloud provider and you, the customer. It seems like a simple concept on the surface, but trust me, the devil's really in the details here.
The fundamental principle goes like this. The cloud service provider handles security of the cloud. They secure the underlying infrastructure, physical security of data centers, the physical network, storage systems, host servers, virtualization layers. Basically, they make sure the cloud infrastructure itself is secure and available 24/7. You, the customer, are responsible for security in the cloud. This includes everything you deploy or manage within that cloud environment. We're talking about your data, your applications, operating systems you control, network configurations, access controls, encryption settings. All of that falls on your shoulders. And here's something really interesting. This model doesn't just apply to security. It extends to things like resiliency, compliance, and even sustainability. Now, here's a statistic that might surprise you, and it's honestly pretty sobering. Around 99% of cloud security failures stem from customer misconfigurations, not cloud provider flaws. Let that sink in for a moment. That really drives home why understanding your part in this equation is so absolutely critical. Let's look at how the big three cloud providers handle this, because there are some subtle but really important differences that you need to know about. AWS keeps things pretty straightforward with their approach. They're responsible for security of the cloud. That's physical hardware, host servers, storage systems, databases, network infrastructure. AWS calls this the undifferentiated heavy lifting that they handle for you. You handle security in the cloud, operating systems you manage, data encryption, network firewall rules, all your customer data. Here's a perfect example. Making sure your S3 buckets aren't accidentally exposed to the entire internet. That's completely 100% on you. And I've seen organizations learn this lesson the expensive way, believe me. One misconfigured bucket can lead to massive data breaches and regulatory fines. Microsoft Azure takes a slightly different approach that's worth understanding. Azure handles data centers and all the physical layers, while you manage identities, devices, and customer data. What's particularly interesting about Azure is how the middle layers, things like operating system, network controls, applications, the responsibility for these shifts depending on exactly which service type you choose. Using an Azure virtual machine, you manage the operating system patches and updates. Using Azure CIQL database, Azure handles OS patching automatically. It's more nuanced than AWS, which can be both really good and potentially confusing if you're not paying attention. Google Cloud Platform emphasizes their deep infrastructure control, and that's partly because they actually build their own hardware. Google controls the hardware layer, boot process, kernel, storage layer, encryption, network equipment. They log everything they're responsible for, which is actually pretty comprehensive. On your end, you handle the guest operating system, network security rules, authentication systems, identity management, web application security, deployment configurations, usage monitoring, access policies, and of course, all your content. But GCP goes a step further with something they call shared fate, where they actually partner with customers to improve security. They provide detailed blueprints and recommendations for secure deployments, which is honestly pretty helpful when you're trying to get things right. Now, here's where it gets really practical and where you need to pay close attention. Your responsibility level changes dramatically based on the service model you choose. With IaaS, you have the most responsibility by far. Since you're essentially renting virtual hardware, you need to secure the operating system, including all those security patches, middleware, applications, and all your data. You configure network access controls, ensure data encryption both at rest and in transit, set up a backup and disaster recovery procedures for your virtual machines. The cloud service provider handles physical infrastructure, virtualization layer, and cloud networking. It's really like having your own server just housed in someone else's data center. You get the benefits of their infrastructure, but you're still managing most of the security stack. PaaS shifts significantly more responsibility to the cloud service provider. They manage the operating system, underlying platform components like databases and application runtimes, platform network infrastructure. Your focus shifts to securing your application code, the data within that application, configuring platform-specific settings like database access controls or application firewalls. If you're using a managed database service, the cloud provider patches the database software automatically, but you still manage user accounts, permissions, and data encryption within that database. It's a nice middle ground that reduces your operational overhead. SaaS represents the least customer responsibility for infrastructure security. The cloud service provider manages almost everything. The application itself, underlying infrastructure, the platform it runs on. Your main job typically involves managing user access and permissions within the application, plus ensuring security and integrity of any data you input into the service. Take Microsoft 365 as a perfect example. Microsoft secures the infrastructure and the application, but you still manage user identities, set up multi-factor authentication, control who accesses sensitive documents. You also need to prevent the data leakage by properly configuring tools like Microsoft Purview. Even with SaaS, continuous compliance monitoring and access tracking remain absolutely crucial. So why does understanding this model matter so much? Well, because misconfigurations remain the leading cause of cloud security failures. If you don't know where your responsibility begins and ends, you're almost guaranteed to leave critical security gaps. And nobody wants to be that organization making headlines for all the wrong reasons. The shared responsibility model helps organizations in several really key ways. First, it helps you avoid security blind spots and allocate your resources way more effectively. When you know exactly what you're responsible for, you can focus your security efforts and budget where they'll have the biggest impact. Second, it enables much more informed decisions about security controls and investments. Instead of just guessing what you need, you can make strategic choices based on your actual responsibilities. No more throwing money at problems that aren't even yours to solve. Third, it guides implementation of appropriate safeguards for your data, applications, and infrastructure. You can build layered security that covers all your bases without unnecessary overlap or gaps. And finally, it improves your engagement with cloud providers. Understanding their capabilities and what you need to manage yourself leads to better partnerships and much clearer communication. This knowledge translates directly into stronger cyber resilience for your entire organization. It's not just theory, it's practical day-to-day security management that actually works. One thing I've really noticed working with organizations over the years is that many assume their cloud provider handles way more than they actually do. This assumption can be genuinely dangerous. The cloud provider might secure the infrastructure absolutely brilliantly, but if you misconfigure a database or leave default passwords unchanged, you're still completely vulnerable. Security in the cloud requires active participation from both parties. It's truly a partnership. Looking ahead, I expect this model will continue evolving as cloud services become even more sophisticated. Zero trust architectures, serverless computing, AI-driven security tools, all of these are changing how we think about responsibility boundaries. But what remains constant is the absolute need for clear understanding of who does what, when, and how. And that wraps up our deep dive into the cloud shared responsibility model. We've defined the model, examined how AWS, Azure, and Google Cloud Platform implement it, and differentiated responsibilities across IaaS, PaaS, and SaaS. This really is fundamental to cloud security. Absolutely everything else builds on this foundation. Next session, we'll move into securing cloud compute services, where we'll put all these principles into actual practice with the real-world examples and configurations. Don't forget to give this video a thumbs up if it helped you out. and make sure to subscribe for more insights like this. Also, check out our blog for a detailed article on this topic. You'll find the link right there in the description below.